Hello everyone, this is Unofficial Sandal. Today I'm going to introduce standard Bloom filter as a series of big data in AI domain interview. I'm using Lintcode 556 as example to guide you how to implement it. If you like these videos, please support me by subscribing my channel. You can find complete code and video list in video description below. I'm refer you to looking at another of my videos to design Hashmap uh, before you watching these videos so that you can compare those two data structure. As you may notice, if our data is very big, there's a lot of key, then to use Hashmap to cache and search maybe is not spatial efficient since we need to have a whole vector to restore the key as put into a different slots. Then to have a spatial efficient data structure, then we introduce Bloom filter here to store all the keys as a array of bit. Then it also can be used to test whether an element is a member of a set. So to use as this purpose, of course, the basic operation is add operation, and another operation is a contain operation. I get into the contain operation in later slides. To implement the Bloom filter, we need to design multiple hash function. So here I will give an example of I build a Bloom filter by using 3 hash function. For each hash functions, we need to define the cap and seed. The cap here is the length of bit array in Bloom filter. And the seed here basically shows how we calculate our hash function. Then the seeds can be different for each hash function. So each hash can map in the key into a different value. So let's take an example if I want to add AB in Bloom filter. So here we input AB here, then we need to iterate all the characters in the AB. Then for first hash function, is seed is 0. Then the result here, basically the result multiply 0 plus C. C here is the A. When we use A in an integer, we use its ASCII values. So right now the rest is 65, and we do the mode of capability, which is 2. So for the next iterations, we come into B. Then the 2 multiply C is 0, so then plus C. So B ASCII is 66, the result is 66. It's not related with A anymore because it's multiplied 0. Then we do 66 mod by 7, then which is 3. So this is our output of the first hash function. Then we do the same thing for the AB in second hash function. The result is 5. And after that, third hash function is 0. After we've done all the hash functions, we put the result as representative of the existing in the bit array. So here we have 3, 5, 0. So 0 is the rightmost first slot. We put it 1. Then we put 3 as 1 if it's not 0, 1, 2, 3. So here is 1 represented by 3, and here is 5 correspondingly. So next we adding CD in here. So for remainder, we already have current array as put those 3 slots as 1. So we run the 3 hash function in CD again. Then we obtain the 250. Then which means we need to put the slots 250 as 1. So 2 here previously is 0 here. So we put 1 and the 5 1 2 3 0 1 2 3 4 5 originally is 1, so we don't need to do anything. and the 6 we need to put it as 1 as well. The downside of Bloom filter is that it will generate a false positive. This is the price we pay for spatial efficiency. So for examples, for the current array, if we want to find whether AE is already be added in the elements, so we do 3 hash function to AE again, then it turns out the result is 0 to 3 to represent this key. So let's check 0 to 3 are all exist in the new array or not. So 0 is here, is 1, and 2 is 1, and 3 is 1. So if we here we run the AE to check whether it exists, this array will tell us it exists. But however, we haven't added AE into the array before. This is how a false positive check will be exist. Then, of course, to overcome the false positive, we can use multiple, more than 3 hash function, right? So we'll generate like multiple combination of the binary array, and then we can also generate increase the capability of the array to longer size. Okay, so 556 problems basically is asked us to implement a Bloom filter with k hash function. Then we need to implement the add and the contain operation. The example is straightforward. If you have decided this Bloom filter as 3 hash function, then add a lint and a code. So after we finish that, we need to check whether it's contained lint in the word. So it's supposed to return true and false. And the same thing for the example 2. Then here is how I implement the stem Bloom filter. You also need to add the hash functions class I implemented before. So you can find that function in the previous slide. During the construction, input is the k hash function. So you need to set the kind of the largest bit size, which is capabilities in hash function. Then I'll generate an instance of the hash function by given the capability and the different seeds. So the seed here is kind of tricky. The way I use that is I'm trying to give you each seed as a prime member, a prime number. So it could be like based on your index and multiply 6 plus 1. Most of the number are primes. And then create a bit array, initialize all as false. Then in add stage, the input is word, going through all hash function, then get the index represented by this hash function. Then we set all the slots in the bit array as true. And in contains operation, again, we go through all the hash function, then get its index. If we had one index doesn't equal to true in the bit array, we return false directly. Otherwise, after we check all the index, we will return true. And here is my performance on the Lintcode. You can compare with your own version. And that's all I want to today. Hopefully you enjoyed the big data session, and let me know any question you have by commenting as below. See you next video.